All right, chapter 10, section 5, angle relations in circles. This is a lot of rules. Please study these and understand them. Tangent and intersected chord theorem, it says, if a tangent and a chord intersect at a point in the circle, at any point in the circle, then the measure of each angle formed is half the measure of its intercepted arc. So pay attention to what this means. I'm going to give you measurements, okay? This is just an example. It's not always going to be these measures. For example, if this arc in blue was 250, okay? Looking at it, let's say this arc in blue is 250. I'm also going to label it, this is BCA, just so we have it. We know what I'm talking about. If arc BCA is 250, they want me to find the measure of this angle. What is the measure of this angle? It's half. So all I have to do is take that 250, divide it by 2, and it's going to give me 125. Okay, that's how I'm finding my answer. Now, if I were to do it the other way around, if they gave me the angle and I'm trying to find the arc, I'm going to have to multiply it by 2. So please be aware of the difference. Looking at the next one, let's say this was arc AB is 110. 110 plus 250 is going to give me 360. And they're asking me to find the measure of angle 1. I have to divide it. 110 divided by 2 is going to give me this measurement, which is going to end up being 55 degrees. So please be aware on how we're getting our answer. You're multiplying by 2 if you're going from angle to arc, okay? So if I'm going from angle to the arc, I'm multiplying. If I'm going from arc to angle, I'm dividing by 2. Keep in mind as well, it's the angle on the tangent line. I'll make a note of that. It's the angle on your tangent line. Okay, it's not just the angle in the circle, it's the angle to the tangent line. So if you're looking at it, you could see that I went all the way to my tangent line. I didn't stop in my circle. Angle inside the circle theorem. Okay, this is more like a floating angle. Okay, so these are like my floating angles. If two chords intersect inside a circle, so looking at it, I have two chords intersecting inside the circle, then the measure of each angle is half the sum of the measure of the arcs intercepting the angle and its vertical angles. Okay, so these are the vertical angles, and these are the arcs intercepting the angle. So looking at it, just giving some sort of measurements. Really quick, I want you to be aware, I'm going to write it on here. If I'm looking at this, you need to understand that this is not central or inscribed angle. So this is not central or inscribed angles. So I can't use those rules. Okay, I can't use those rules. Remember, central angles were at the center. My central angle is the same as my arc. Inscribed angles were half the measure of the arc. But this is neither. Okay, so be aware of that. It's not central or inscribed. All right, so looking at it, we're trying to find the angle measures. Keep in mind your chords are straight lines, so they're 180. So if I find angle 1, it should be pretty easy for me to find angle 2. Or if they're not giving it to us like that, you can just use the arc measure. So I'm just going to go ahead and give you some arc measures. Let's say this is 40. This is 120. This is 80. So looking at it, if it wants me to find the measure of angle 1, how would I find that? I need to add my two arcs. Okay, my two arcs, and then divide it by 2. So looking at it, I'm going to have, looking at this example, I'll just write it above it. I'm going to have 80 plus 40. Yes, you can multiply it by 0.5, but I like to just divide it by 2. So I'm dividing it by 2. What's 80 plus 40? So I'm going to have 120 divided by 2. And what's 120 divided by 2? 60. Okay, so now I know my angle measure. The measure of angle 1 is going to be 60. This is also going to be 60 because they're vertical angles. And looking at the next one, how do I find the measure of angle 2? How can I find the measure of angle 2? Let's say they weren't giving us the measure of angle 1. Let's say that wasn't there. I first need to find my arc. How can I find my arc? What's arc BC? Yes.
I was going to say, to find arc BC, you add all of them.
Okay.
40, 80, and then 20, and then subtract them from 360.
Okay, so I'm going to do 360 minus adding all of them. 120 plus 40 plus 80 is going to give me 240. And subtract, I'm going to get 120. So this arc right here is 120. And then how can I find the measure of angle 2? Yeah.
Using the linear theorem that says that the line is 180, so you would do 180 minus 60.
Okay, I could do 180 minus 60, but let's say they didn't give me that 60-degree angle. How would I find the arc? How would I find the angles using the arc? Okay, so let's say they didn't give us that 60 degrees. Let's say I didn't know that those were 60 degrees. How would I find angle 2? Yeah.
You add 40 and 120, and then you divide by 2.
I'm adding which ones?
40 and 120. Oh, never mind. 120 and 120.
Okay, good. So I'm going to add 120 plus 120 and divide it by 2. That one should be pretty easy. 240 divided by 2, which is going to give me 120 degrees. So yes, this is 120. And I used that again. For example, if I didn't get that 60 degrees, that's how I'm finding out that angle. But because they did give us that 60 degrees, I could have just done 180 minus 60 and also got 120 as well. So it's up to you how you want to solve it. So just showing you again where I'm getting these from. We solved for 60 by plugging it in here. That's how we got our 60 degrees. And then we solve for 120, either by using the rule. Okay, so adding my two sides, dividing by 2. Or you could have done 180 minus 60 because they're giving me that 60-degree angle. But again, if they weren't, you have to use the rule. Looking at the next one, it says angles outside the circle theorem. Please pay attention to this. If a triangle and a secant, two tangents or two secants, what did I say? If a triangle? No. If a tangent and a secant, two tangents or two secants intersect outside a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. Please pay attention to this. There are 3 types of circles that I could use for this rule. Looking at my first one, what do I have here? Is this a tangent and a secant? Is it 2 tangents or 2 secants? Good, this is 2 secants. Looking at my next one, what do I have here? 2 tangents. And then my last one, what do I have for this one? A a secant, and a tangent. I know this doesn't really look like a tangent, but it touches the circle at one point as best as we can draw it. Okay, so the rule for this is, for all of these, how am I solving for the measure of the angle? Keep in mind, you're using this rule. You can really solve for anything once you know the rule. So please follow along to what the rule is. It is big arc minus little arc divided by 2. Okay, where am I getting this information from? Please pay attention to this, because once you know the rule, your life is going to be a lot easier. So, looking at it, my big arc, okay, it's my big arc for all of them. Let me get orange. Okay, my big arc, looking at it, please pay attention to what the big arc is. So looking at this is my big arc right here. Looking at my two tangents, this is my big arc right here. And looking at a tangent and a secant, this is my big arc right here. Keep in mind, these lines can go straight through. Okay, they normally go straight through, so if you're looking at it, you're saying, oh, but it doesn't go straight through, you may get ones that go straight through. Okay, so that's my big arc. Now we got our big arc covered. Now looking at my little arc. My little arc is going to be this little one right here, this little one right here, and this little one right here. Okay, keep in mind it doesn't go straight through, it stops at the intercepted arcs. And then I have equals, I forgot to write, equals my angle. So how am I going to find my angle? My angle is the intersection outside my circles. Keep in mind you can use this rule to solve for a big arc. You can use this rule to solve for a little arc, or you can use this rule to solve for an angle. You can find anything using the rule. But please pay attention to what you have, because some of them are not looking at the entire thing. Circumscribed angles. A circumscribed angle is an angle whose sides are tangent to a circle. Okay, so I have two tangent lines. This is my circumscribed angle. So it's specifically the angle. Circumscribed angle theorem. The measure of a circumscribed angle is equal to 180 minus the measure of the central angle that intercepts the same arc. So, looking at the rule, I'm solving for my angle. Keep in mind, again, you could solve for something else. This angle equals 180 minus my central angle. Okay, so please understand that it's 180 minus my central angle, and that's going to end up giving me my intercepted, or my circumscribed angle. All right, looking at these examples, let's go ahead and see what we have to solve for. So the first one, the directions are telling me UT is tangent to the circles. So again, it may not look like it's tangent, but yes, it touches the circle at one point. It goes right there, touches it at one point. All right, next. A, they're asking to solve for arc WT. So looking at it, finding arc WT, which is right here. Let me highlight it. WT is right here. This is what I'm trying to find. Okay, so this is the first one that we're doing. Arc WT. How would I find the measure of arc WT? Who can tell me? Look what I have. Looking at arc WT, I have a secant and a tangent. So how would I solve for arc WT? I'm trying to find the arc. What's the rule that I'm gonna need? What's the rule I'm gonna need to solve for this? Yes.
The measure of the arc divided by 2?
It's a little more than just the measure of the arc divided by 2. It's a rule. Keep in mind, guys, I have an angle outside the circle. So what's the rule for angle outside the circle? What's the rule? What is it, Gianna?
Big arc minus little arc.
Big arc minus little arc, what else? Yeah. Divided by 2 equals your angle. So that's the rule. You guys have to remember it. This lesson is a lot of rules. You have big arc minus little arc divided by 2 equals your angle. So, looking at it, who could tell me what my big arc is?
100.
I'm going to do 100 minus, what's my little arc? Do I know? No, so I'm representing it as x. Divided by 2 equals, do I know what my angle is? What is the angle? 30. So solving it, what do I have to do first? Good, multiply both sides by 2. I'm then going to get 100 minus x equals 60. What do I have to do next? Good. Subtract 100 from both sides. I'm going to get negative x equals negative 40. Divide by negative 1. I'm going to end up getting x equals 40. And that's my answer for my arc. 40 degrees. Okay, please make sure you're aware of the rule. Big minus little divided by 2 equals your angle. I'm just going to write it somewhere else so I have space for my answer. You guys have to remember that rule. Okay, so the answer for the first one we found out was 40 degrees. All right, looking at the next one. Angle TVS. TVS is right here. This is what I'm trying to find. So looking at it, how would I find this angle? Yes. Yeah, go ahead.
100 plus 30 divided by 2.
100 plus what?
30.
Not 30. Look at what I have. I'm looking at that floating angle. How would I find that angle? What am I going to use for that? Okay, angles inside the circle. What's the rule for using angles inside the circle? Yes.
40 plus 40 divided by 2.
What was it?
40 plus 40.
Why 40 plus 40?
Because 40 is your angle. Oh, never mind.
Yeah.
100 plus 110 divided by 2.
Good. 100 plus 110. 100 plus 110 divided by 2 is going to equal my angle. So adding everything, I'm going to get 210 divided by 2. If you divide it in half, you're going to get 105. Guys have to know these rules. All right, looking at the next one, angle RVS. Okay, RVS is right here. That's the angle I'm looking for. How would I find this angle? How would I find the measure of angle RVS? This one should be easy. How would I find that angle? Yes. Good. 180 minus 105. So 180 minus 105, what am I going to get for my answer? 75 degrees. And looking at the last one, arc RS. So that's this arc right here in orange. How am I finding my arc? How am I finding that arc? Look at what you have. Look at what's given in your circle. How would you find the rest? Yes.
Wouldn't you add 110, 40, and 100, and then minus 360?
Good. So you're going to find the remaining piece of the arc. They're giving you 110, they're giving you 40, they're giving you 100. So they're basically giving you the entire thing except what's missing. So if you add everything together, you're going to get what? 250? So they're going to do 360 minus 250, and if you subtract it correctly, you should get 110. Good. Okay. All right, again, you guys have to remember the rules that you need for these. Do we have any questions on this example? All right, looking at example number 2, it says the measure of arc AB is 105. So this right here is 105. They want me to find the measure of angle D, of this angle right here. So what do I have here? If this was drawn correctly, I know it doesn't look like it, but I have two tangent lines. There's one, and here's the other. What's the rule to find my angle outside my circle? What's the rule? What is it? What's the rule to find the angle outside the circle? Yes.
The measure of the center and the left intersects the same arc.
No, we're not going to use that one. Okay, guys, you have to look back at your notes. This is the angle outside the circle. Laura? Big arc minus little arc divided by 2 equals your angle. You have to differentiate which one you're finding. Big arc minus little arc divided by 2 is going to equal my angle. Do I know what my big arc is? Yes or no? No, but can I solve for my big arc? Yes. How would I solve for my big arc? Okay, so this right here in blue is my big arc. How am I solving for my big arc? Yeah. 360 minus 105. 360 minus 105, what is that going to give me? This is 255. What's the measure of my little arc? We know it because it was given to us. That's my 105. And I'm solving for my angles, so plug everything in that we have. I have 255 minus 105, dividing it by 2, and that's going to give me my answer if I solved correctly. What am I going to get? I'm going to end up getting 150 divided by 2. If you divide correctly, your answer should have been 75 degrees. So please make sure you understand how we're getting this. Again, you have to know what rules you have. Right here, we said we have 2 tangents. All right, looking at this one, what do I have? I'm going to have 2 secants. Okay, what's the rule for this? Can anybody tell me what's the rule when I have 2 secants? Yes. Good. Big minus little. divided by 2 equals my angle. Do I have enough information here? Yes, I do. I'm solving for my big arc. I have my little arc, which is 20. And then they are giving me my angle, which is 10. So plugging in what I have, I'm going to have x minus 20 divided by 2 equals 10. And solving for x means I'm multiplying both sides by 2. X minus 20 equals 20. And then adding 20 to both sides of my equal sign. So my big arc is going to equal 40. Okay, again, please make sure you're aware of what they're giving you. Questions on this one? All right, looking at my last one, find the value of x. What do I know about this one? Yes.
180 minus the central angle.
Good. Okay, 180 minus the central angle. Now we're going to use that one. So 180, what's my central angle? 135. If you subtract correctly, what are you going to get? So x equals 45 degrees. Okay, so please understand the difference if they're giving you the central angle, if they're not giving you the central angle.